Oh, you got the sound? Yeah.
Yeah?
Yeah.
Anyone can confirm if the sound is working, please?
Sound is working. There you go.
So, okay. Can you see this one? Yeah. Cool. So, oops. Good afternoon. My name is Rachel. I'm part of the DS4. My class today will be about predictive analytics. Sorry about the fact that I'm always putting the accent in the wrong part of predictive and also analytics, but I think that it's part of my Portuguese accent, so sorry about that. What we'll do today is, it's a quick introduction to predictive analytics. Then we will go to Alteryx and do few exercises. And I choose two different types of exercise that we'll cover today. One about grouping and the other about modeling. I think that those are the main, they are the most important kinds of analysis that you do, predictive analysis that you do in a sense. So before going to Alteryx, just a few words about predictive analytics for those that, like me, come from another area, another background, and are not used to this kind of things. So what exactly we will do? What exactly we do when we're working with predictive analytics? So in a sense, what we're doing is creating a kind of statistical model that will help us to understand, help us to figure out relationships in our data, and help us also to have insights. We can use predictive analytics to understand better things in the present, but also to predict things in the future. Those are the both things that we'll be doing today. We'll work with grouping, that is something related to the data that we already have, and we'll also work with regression, that is something that will be predicting the future, what will happen in the future. So I got this figure in the problem solving with advanced analytics. It's a course in Udacity. If you'd like to check and to see, it's interesting. Part of the course is obviously only the basic parts are for free. But you can see there are interesting things about, interesting basic things to understand better what exactly it is. Basically, this framework is showing what we need to do during the use of the predictive analysis. So first thing, we use it, we need to understand exactly what we're trying to answer. So we need to have a good knowledge about the data that we have. We also need to have a good knowledge about the situation that we're trying to forecast. After that, we need to prepare the data. Sometimes you need to get more data from other source. And then when you have data enough, that at least the data that you think that is enough to answer your questions, you start the part of creating the model, validating the model, and then finally doing the presentation or visualization. Quickly, before going to the models or for the tools in Alteryx, it's interesting to remember that we have two types of variables. We have continuous and categorical. It's important because, as we see now, different types of variable will be used in different models, different kinds of predictive analysis. Today we will be working with one option, that is this, in this line. We'll get numeric data. In our case, we work with sales, and we will try to discover. We will receive 9 options to open a store, and then based on the sales data from other stores, we will try to discover which store is the best option. So we will working with this part. We will have a file that we have enough data to do the model. It's numeric, it's continuous data that we work with, and we work with linear regression, boosted model, and a third model to compare. And we will be also working with segmentation, that we will be using a cluster to analyze beer. So few examples. I think that nowadays we can think in lots of examples where you can use predictive analysis. I think that we are, in a sense, all the time being guided by predictive analysis, kinds of predictive analysis. So, for instance, when we go to the supermarket, the way that we see the products displayed in a shop, it sometimes they choose this way and not another way because they performed analysis before trying to discover which are the combinations. So, for instance, you put, I don't know, let's think, someone can help with British habits, something like this. Which kinds that you buy together?
All the way at the back, so that everyone has to walk through everything else together. Bread. Everyone wants bread.
Yeah.
Milk and milk.
Milk and bread.
Yeah.
Any other kind of specific beans? Yeah, it's interesting because, for instance, for us in Brazil, there is a combination that is rice and beans are products that need to be together because we eat rice and beans all the time together. So when you go to the supermarket, you expect to find those things together. It doesn't make sense here because I think that it's not the same, that you don't have the same habits of consume, but yeah. It's interesting because grouping, in a sense, doing a cluster can help you to identify, not a cluster, but grouping can help you to identify this kinds of pattern between habits of consumption or things like that. Another thing that you can use, for instance, you can predict the consume of energy. And I noticed that here in UK, the companies do it a lot, especially because happened something fun with us, because we use or to heat the house, we use gas, not energy. But now when it started the winter, not the winter, but it started to get colder, the energy company sent us a letter saying that they would be increasing the value of our tariff during those months. And then we needed to call and explain, oh, look, we don't use electricity to heat the house, so it will not, there is no difference between our consumption of energy during the summer or during the winter. But anyway, they didn't know that. So they expect that during the winter months, the consumers will consume more energy than in the other months. So here I put few situations that we can use prediction. We can try to predict things. Another thing is, for instance, how a virus would spread. It's more in a scientific area, less in a commercial area. Another thing that it's interesting, for instance, about virus, that's because recently I did before coming to the DS4, I did an article that it was about the foot and mouth disease here in UK. And one of the problems that they had was they worked with a terrible model. That's the reason why it was a catastrophe, because the model that they were working, trying to imagine how would be the spread of the disease, was completely wrong. So it's something interesting because a model can help you, but a bad model, I don't know if it's a good way to describe the model, but a model that's not well constructed, well built, can also make you fail terribly. So a little bit about Alteryx. Why will we use Alteryx to build models to try to discover, to try to predict things? Well, first thing, I think it's easy to use. You don't need to to know nothing about code. You don't need even to know how the algorithm works. It's something like, for instance, me. I can use it, and I can show you something in the end. I can tell you something about the data. We don't need to have lots of technical knowledge to use Alteryx to do that. Obviously, you need to learn how to analyze the data, but you don't need to be an expert. You don't need to know how to code. Another good thing is that it's easy to test, so you can compare results and then you can choose what is the best. And for those, it's for Willem. It's technology based in R. You see when we go to Alteryx that there is an R in some of the tools. When you see the R, it means that you can click and you can see how the code works. If you know how to code, you can change it and you can create new things. So briefly, today we will be working, I told you, we'll be working with group and modeling, but those are not the only ways to work with predictions in Alteryx. Here I put an image just to give you an idea that we have all the ways to, and all the possibilities and all the predictions that we can also create using Alteryx. So let's go to our first example that is about grouping. I will start with that because it's faster than the second that we work. I think that it will be more fun to start with this, that it's easier, and then we go to the modeling. So we'll be working here with cluster analysis. Cluster analysis, basically what we will do is try to create a group based on continuous data that we have about, or dimensions about, or about the thing that we're analyzing. We also can create groups based on categorical data. That is the example that I gave before about the supermarket. For instance, it's a categorical data. You know the products, but it's not a number. But today we will be working with numbers. So we will be working with a cluster analysis based in key means. That is, well, I think that at this point I will explain while we're doing it. It will be easier. So basically just for those that have never heard about cluster analysis before, the idea when we create a cluster is to create groups, and I think that if you go here just to see, whoops, there is something. Oh, you cannot see my, are you not saying Tableau? Yeah?
No.
No. Whoops, just a minute, because there is something weird happening here in the transmission.
You're just showing the screen, not your window.
And it started to do it.
So click on. Is a little way drop down there. Yep. And
Screen. Yeah. Oh, here we go.
Yep.
Well, I'm not with the best, but okay, we have here a few bubbles, so we can think about those bubbles in a sense. What the cluster will try to do is to create groups here, trying to make the distance between the bubbles that are inside the group the smaller possible, while it will also try to make the distance between the bubbles inside the group and the bubbles in the other group the bigger that it can. So it will try to emphasize the difference between the data that we're working. Oops, sorry. So it is basically what we will do while we work with, oh, sorry, I lost here where we are.
You can hold down the Shift key and then press F5 to start the thing from whichever slide you're on.
Shift?
And F5.
And F5. Okay. So now what we'll do is we'll create a cluster analysis using Alteryx. Basically what we have is we received data about several beers, and our client is creating an application to suggest beers to its users. So you would like to create big groups, to group those beers in big groups, to start to suggest you. For instance, if you mark in your app, I like this beer, then it will suggest you another beer that it's classified as similar to that beer that you like. So we received it from our client data set, and it contains information about the beer size, the brewery, the style, the ABV, and the IBU. And based on that, we'll select the data that we need to create the 4 big groups. Here, I'm showing one of the possibilities, but it's not what we're doing. Here, it's a visualization using the same data, but you can see that here in this visualization, what they are doing is you have the average of IBU and average of ABV. But if you think about, for instance, beers that are here, can you see where I'm hanging? Yeah. If you think about beers that are in this area, they are more similar to beers that are here than to beers that are here in the other side. But if you get only averages, they will be grouped in the same group. So that's the reason why we will try to create another way to group this, another way that will ignore these averages, and we'll try to get the similarities about the beers. So let's go to our friend Alteryx. And what we have here is the file with the beers. We can see here, we have the beer, the brewery, the location, the style, the size, the ABV, and the IBU. Working with cluster analysis, we can only use continuous data. So unfortunately, we cannot use the style, for instance. We need to choose the continuous data that we have here. I use ABV and IBU because I think that size is not very important. What do you think? Without size? Yeah, because I think that there is no sense in putting a size as one of the... So the first thing that we will do is, let's do a select here. Oops. In the select, what we can do is, we don't need this number, okay, this first string, but we can also in the select change the ABV and the IBU, because as you can see, we are seeing them as strings and not as numbers. And we need them as numbers, because if they are not being identified by Alteryx as numbers, the tool that we use to do the analysis will not work. So let's put them as doubles. Okay. And here we go. Now we have the same data, but without the first column, and ABV and IBU are being identified as numbers. What we will do now, we will start the analysis. And to start the analysis, we will discover this beautiful new part in Alteryx. There is the predictive grouping, this green part with grapes. It's better to analyze wine than beer, I think. But today we're analyzing beer. So what we will do, we will get here this tool. It's the key central IDs cluster analysis. And we will create a field called group, where we will put our groups that will be created. We'll select the fields that we will use, and we are seeing ABV and IBU here only because I changed it to double before, because you cannot see that the other data that is marked as string, you can see that we have things here, we have more data here, but they are strings and not numbers, so we cannot see them here inside the key central IDs cluster analysis. And okay, we are using key means instead of key medians. It's more for a reason of best practice than any other thing. It's more used, this kind of analysis, than key medians. And we'll choose in our briefing, we had, it was to create a division of our beers in 4 big groups. So we'll choose here 4 clusters. It will be the number of clusters that you have in the end. Okay, it's done. We have the number of clusters. We have the key means marked. What we need to do is to run it, and now we will have the clusters created. This tool is creating the clusters. However, as you see here in the end, when it finishes running, we need to be a bit patient because Alteryx is analyzing the data, so it needs a bit of time to do that. But while we wait, we can still analyze it, because what you have here is the creation of the groups. However, we will need to append it again, because look, that is the data that is in my out. And here is the part where we can see the R code. You can note that we have the O and the R. Yes? Everybody follow me?
Yeah.
The R is the part where you can see exactly what is happening in the part of in the coding part of Alteryx. And here in the O, you have the output. That is what we need to connect again with our data to put the groups together with the information that we had before.
It's the object. It's the R object.
Oh, yeah. The object is the output also, no?
So that O stands
Yeah.
for object.
O
Yeah.
stands for object, R stands for report.
Yeah. Yeah, the report is not very, well, obviously, if you know statistics, probably you love it, but I can show you, just for curiosity, if you would like to see how the report is. People from maths, the statisticians, you like this. It's not so. For me, it's a lot of numbers that it's okay. That's fine. Next life, maybe I can try to understand you. Here we go. You see here in this area our beautiful report. That is the report. Here is. You have the average distance. Here you have the clusters. It created 4 clusters. You have the size of each cluster, the average distance between the points, the maximum distance between the points, and the separation between them. Oh yeah, it's great because now that Paul told about that, the place where you can see the code in reality is here. Open macro, and then if you open the macro, you can see here is what is actually what Alteryx is doing with the data. So if you would like to explore after, you can do the same thing, click on macro, and then see what you're doing. Okay, so now that we have here our object, what we need to do is to connect it to the data, because it's not readable, not for us. So we'll get now the append cluster. Here is. Let's get rid of those things here. We don't need this. We don't need this. And okay, my Alteryx is thinking a little bit about life. But in the append tool, what we'll do is to get this data and now connect back with the other data that we have in our select here before. You need to wait a little bit because I think that my computer is dying, so we need to wait a little bit more. While this, we can talk a little bit about the part of because I didn't explain it, but well, the name of the tool that we are using is key central IDs, and the key is related to cluster. So the meaning of this is that it's the reason that there is this key in the name is it's related to the name of the process that we are doing, that is the clustering. And we still with my Alteryx not working.
You broke it.
Yeah. Let's see. No. I will interrupt. I will stop sharing my screen for a minute. Yeah, it's still not working. Yeah, I think that my computer is all crazy. Okay, I'll wait. I'm back in a few minutes. I want to try to figure out what's happening with my Alteryx. But yeah. My task manager is not open. Okay, Alteryx. Let's see. I will now try to get something that is already done. Open workflow.
It's on screen, I'm sorry.
Yeah?
Yeah.
Okay. Okay. So we are in this part when my computer decided that it wasn't work. My computer says no, but now it says yes. So after this part of the analysis, now we append, and the result of the append basically is, oops, sorry, I will need to connect all the data again because I opened the Alteryx again. So just a minute. Clustering, beer, okay. Go Alteryx. Now we need to wait it to run it again, and if it all works, we'll finally see our data with the groups. If you have any questions while Alteryx is thinking about life and they would like to ask, you can ask.
How is this different to the clustering in Tableau?
We can see after the results are slightly different. I don't know exactly why, but we can compare here after. We can show it in Tableau and do the same cluster in Tableau and see the results. How do you know the reason why?
Random seed. So clusters are always built by throwing out random seed points and then trying to work out the distance between them and minimizing that distance.
So like an algorithm that keeps repeating.
And it just Alteryx and Tableau end up with fractionally different random seed start points. Yeah. So their clusters are going to change a little bit. It's usually not significant.
Yeah, we can see now that, for instance, in this example, we can see how the groups will be different and the grouping by Alteryx and the grouping by Tableau. If my Alteryx decides that now it's time to work. So let's see here.
The thought being that when you get to bigger data sets, having your clusters appended to your data set before it goes to Tableau speeds up the process.
Yes, performance. Yeah.
So I saw in Alteryx you can change the number of random iterations you do. Can you do the same in Tableau?
You can pick how many you want.
Right.
That's it.
Okay.
You can pick what is used
As in
to
how many clusters you want.
Yep.
Yeah.
So you can't pick how many times you want to like
Try and
rerun
read-
the algorithm and then that's weird.
and you don't have as much tuning power to decide what side, how many clusters you want, what the clusters are, or why that number of clusters is chosen, which you do get in Alteryx.
Right, okay, so it's basically just better to do it in Alteryx.
Yeah, you get a lot more flexibility and control.
Yeah.
And yeah, you can use k-medians rather than k-means. You can use different clustering algorithms as well. Then if push comes to shove, you can go and use complete different clustering programming tool from R and bring that in if you want to as well.
Well, so let's do the test in Tableau now. We can save this. Use this and show it in Tableau how the groups will work, and then we can do the comparison, and you see that the result is slightly different if you do with the Alteryx or with the Tableau function to create clusters. So come on, Tableau. Maybe it can. Yeah. Well, here it is. Now we can open. Why it's not open? Here it is. Okay. So we were comparing ABV and IBU. Oops. Idea. I will duplicate this sheet, then after we can do the comparison. And here are our clusters. Oops, sorry. Our clusters, and I put it in the other way. Here it is. That is the analysis made in Alteryx, the clusters that we created in Alteryx. Now let's do the same thing. Creating clusters here in same number of clusters, 4 clusters. Here is, as you cannot see, the result is very different, especially because Tableau, for instance, created a not clustered thing here. And for instance, this cluster is very, very small compared to the others. And here in Alteryx, we can see that they are more populated in a sense. The cluster have more beers, each one. Okay, so the second part that we'll do, second analysis that we'll do now is showing how to, oops, how to work with models. And in the case of the models, different of the, because what we did now was we had data about beers, and we're only trying to group a data that we already have. With the models, what we try to do is to get an answer for a situation that is in the future. We're trying to predict something in the future. So usually, based on information that we already have, you try to answer a question. And to create the models, you have two basic things. One is the target variable. That is the variable that we're looking for an answer. And you have also the predictive variable. The predictive variable are the variables that you use to answer your question. So for instance, we work with sales. Sales will be our target, and we'll try to find predictive variables that can help us to discover how the sales are affected. Basically, what we'll do, we'll follow these 3 steps. First thing, we will give to the algorithm. The algorithm is already done in Alteryx. What we'll do is we will feed the algorithm with some data. The algorithm then, we will do a training and we'll learn from this data that we're giving to it. After that, after this first result, we will validate this process. So we'll see if the algorithm is telling us something that is okay, something that can be real or not. If it's very, we're finding a very strange result. And then only after this part of training and the part of the validation, only after these 2 steps, we will apply the results to our data. So a new question to work with models. We have now a client that has a list of 9 possible locations for its next shop. The client, what they would like to discover is, from those 9 possibilities, which is the best, which is the shop that they should open first. So to help us, he sent 2 other files with data about demographics of the shops that are already, the stores that are already working, and the sales of those stores that are already open. So what we try to do, what we do in Alteryx is, using this data about the stores that are working, we'll try to predict which of the possible stores should be opened first. So let's go back to Alteryx. I need to open everything again because my Alteryx closed all the things that are already here. So I will get here to input the data about the stores and the data about the sales. So I browse. Here it is. We have here the data about stores. Let's open. Here we have the data about sales. Let's open also. And the first thing that we need to do with this is we'll need to, here we can see we have lots of demographics, but we don't have the sales in this. And here we have only the sales. So the first thing that we need to do is to join those things to start to work with the result. So we have here a store ID, in the other store ID, We don't need to have storage it twice. We run, and the result we will have now both things together. That is exactly what we need, because after we need to have both informations in the same at the same time, because the way that the tool works is it will get from this data the target variable and the data that we're using to predict. So it needs to get both things at the same time. So the first thing that we will do is to create samples. We will not analyze our data or full data at the same time, because as I told you, we need to first test the algorithms and then validate if the algorithm is working well. So it's something we can think that you are first making the algorithm exercise a little bit with the data, know the data a little bit more, and then after, with the other part of the same data, you test if all those things that the algorithm learned from the data are real or not. In reality, not if they are real or not, but in this situation, we'll test more than one model at the same time. So at the end, we'll see which model worked better. So here we go. We need to create an estimation and a validation. We don't have here a huge data set, so we can use all the data that we have. Here, as you cannot see, we have estimation and validation. It cannot be bigger than 100 because it's a percent of the data, so it doesn't make sense if I put here 90 and here I put 50. I'm working with more data than I have. It's not possible. It needs to be always less than 100, and it doesn't need to the sum doesn't need to be 100, because, for instance, I could, if I have a very big set of data, I could opt to work with let's say something like 70 and here 20, and I would have 10% that are not being used here. They will, in the end, if you look the tool, they create samples. You see that there is an E, there is a V, and there is an H. The E is the part that we use to estimate. The V is the part that we use to validate. And the H is the holdout. It's a kind of leftover, the part of the data that we're not using. In our case, what we will do, we are using all the data, so we have no data here in the H. So let's run and create our sample. And once you have the sample, now we'll test one thing that Paul told me today that is a good option. If it doesn't work, we'll ask for help here. That because well, I think that I'm more with the, let's see. Yeah, that is the thing that we're building. Don't despair. In the end, it will work. And as you can see, there are a lot. That's the reason why I came with sweets before. Because I thought that, yes, you would be a bit desperate after seeing that. But the question is, as you can see, lots of things will be happening at the same time. So the problem is that Alteryx starts to run a bit slow. So we'll do this best practice that Paul taught me today. I hope that it will work. If it not, we'll do the other way and wait. So what I'll do here is I will put a container, because this way I will put all my models inside the container, because the big problem is while Alteryx is running the models that testing the models, it spends lots of time, it takes time. So if we put the models inside the container, after we can simply kill this part of the workflow, and then it will stop running. It will not work anymore. So we will use three different models to see which is the best one. All those models are used to work with continuous data. So basically, they have different ways to analyze continuous data. And what we'll do here is to check which will give us the best result. So we put here the linear regression, the boosted model, and the spline model. What we will do now is, oops, here we go, we have the three. Each model needs, the first thing that we will do is to feed the model with our estimation, the data that we split before. So I will give estimations for all the models, and then I will now get each one of them. So here I'm working with the linear, and I will configure the models. So the target variable, I need to first thing I need to tell to my model which is my target variable. You remember the target variable that we're working here? Sales. A chocolate for you. And here we need now to select the predictor variables. We don't need, I put all here, but obviously we don't need all. For instance, the store ID, it will not interfere on my data. The site postcode also. The site name also. Latitude, the longitude also. And we need also to remember that sum of sales shouldn't be in our predictor variables because it is our target variable. So now we need to do it for each one. Same thing to this set. No target field, you put sales again, and now get rid of store ID, site postcode, site name, latitude, longitude, and sum of sales. I will start speaking in things in Portuguese. This way you pay attention to what I'm doing when I'm doing this for the third time. So now I will get rid of ID da loja, do CEP, do nome da loja, da latitude, da longitude e do total das vendas. Porque, como eu disse anteriormente, a gente não precisa de total das vendas. Yeah, I forgot this. But in Raj, I said this, but in Portuguese.
Oh, okay. There's no way we know if that's true.
Yeah, that was the problem. Okay. Repeat after me. Latitude. Yeah. See, everybody here speaks Portuguese. It's amazing.
Well, Brazilian Portuguese.
That's the most important Portuguese in the world. There is no reason to speak Portuguese from Portugal. Sorry, there is nobody from Portugal, so yeah, I can say that. People watching, I'm just joking. My husband is Portuguese. It's a kind of thing that we joke usually home. We try to compete to see which Portuguese is more important. So here we have all the models. We did the configuration. Next step is to run to see what will happen. And now you see the big problem. It's been time. Yes. You need time now. Yeah.
Oh,
now,
it says on there now.
I can carry on now. I can start my part with Brazilian jokes in Portuguese, something like that. But yeah, you can see that that's the reason why we're using the container, because we will kill this process after this part.
So what would happen if you missed out a sample step and plugged straight in? Could you do that?
If you, sorry?
You can, you just wouldn't be able to check how good it is. What ends up happening is you get a process called overfitting. So your model is basically going to find a way to map to each individual point rather than trying to predict where the point should be or could be. It's going to create a formula that works out those numbers.
And then you've got nowhere to test it.
Yes.
Got a model. It's just like, great, got a model. Although you don't know if it's right or not.
It's okay, that is quite common. The number of people that create a model and say, oh my god, our model's awesome, put it out in the real world and it doesn't work.
But yeah, in the end, you see that models have limitations. One of the limitations that not always they work. Yeah, I should have. I think that I will do a thing here. Stop it and put an input, because this way, oh, sorry, an output, because this way we'll do two processes at the same time, and then we will not need to wait again and again and again for this part. Because that is the big question, because first time I was doing without saving, and the problem is that each time you need to run, you need to wait minutes and minutes and minutes. So if we do that, it will save us time after. Spline. And as you can see here again, you can see the report. Same thing. It's all those tools are also built in R. So if you go here again and click, for instance, where is our linear regression, and click here, you can see that you can open the macro and see exactly what Alteryx is doing inside this tool. If you'd like to read the documentation, you can also click in help and find more information about how the tool work and what's the meaning of each part of the tool that we need to configure. You can click and see more.
No, I know. I wouldn't have thought of having them ready for the next week. That's how the other commission level, that's fine.
And save this keep, because if it works, I will be very happy, because this morning I waited lots of time because of this thing of running and running and running and running. Well, problem, we need to run again because I'm saving as TDE instead of running, saving as the right format. So sorry guys, we need to do it again. File browse. We need to save in the format that we use after in Alteryx, so IXDB. This way we after can only, we don't just need to open this and we can use it again. While Alteryx is thinking about life, I can show you here. Here are a few links where you can find more information about predictive analytics. So here is the link for the nano degree at Udacity. That is, well, you can, part of the introductory part is for free. The rest of the course you need to pay. Here is the part in the site of Alteryx where you find more about predictive analytics. Benedetta wrote lots of things about this part, so you can go in our website, the Data School, and you can find more. Here she did one, it's a part 1 about clustering, and the part 2 is that we're doing now about sales. So you can find more. There is also, that's very cool, it's an article that I recently read that it talks a little bit about the problems in using algorithms, because it's, as I said before, if your data is not very good, you have problems with your predictions. And here they are discussing this kind of things, for instance, algorithms that are not showing the best ads of jobs well paid for women. So it's a problem because someone created an algorithm in a way that men are preferred to see this kind of information. There is another thing that they discuss here about policing that is also interesting, because if you use always the number of crimes and this kind of things, you have the risk of start to over-police an area that, and obviously if you are over-policing, probably you start to arrest more people that not necessarily committed a crime, and then you create a problem because then you have more people arrested and then you need to police it more, and it's another problem that can happen. So back to our beautiful Alteryx that finished running. What we have now is the model, but the same way that when we did the group, we needed to connect the results that we had from the group and the cluster to the rest of the data. Here we will need to do the same thing again. That's the reason why I saved it, because if I don't save, if you don't do this part, what will happen is that you have the workflow this way, and then each time you need to do one of the following process, it will need to run again, and you'll be all your life waiting for Alteryx run the 3 modules. So this way, you don't have this problem anymore. We can only input your data. We will input all again, and then we can close the container. I'm checking it.
So you haven't disabled the container?
Not yet.
Yeah.
I'll see if they will come first. The posted in here. No, stay here, Paul. Don't go. It's fine. Okay. No, let's go back to, oh no, the container again. How did you solve it the other time?
You've got it selected.
Ah, okay.
Yeah.
No?
Yeah. That's always what I do.
Oh, maybe it's not able,
You
right?
haven't applied it yet. And then click disable, cool,
But-
and then click off. No, that's fine.
That's fine.
It just hasn't been applied, so if you click on some white space with the tick down the bottom corner, you can apply that.
Okay.
Cool.
We don't need to see that, yeah. But it happened again. My container disappeared. Well,
Yeah.
okay, hopefully we not need the container, because if we do, if we need it, we need to find where the container is. That's a way to stop the models, to stop them running all the time that we need to. Because what we need to do now is, okay, we need to connect the data again to see if the model is working well. So we'll get this beautiful score, and we'll put one score for each one. And what we'll do in this score is exactly that. We'll get this data, and we'll connect here with the V. Do you remember that minutes and minutes ago we split our data in the part to use to estimate and the part to use to validate. So we'll go back and get the validation and connect it to our score. And again, my Alteryx is stopping to run. There is something not very cool happening today.
It worked so quick.
No, it's back. Okay. Not yet. Yeah. My computer is tired, sorry. And here we go. Oh, 3 minutes, be patient, please. It's running.
We can just see that it says site investigation not valid.
You can ignore it. It's only because we didn't run.
So what does that use? You plug in just score, and then it gives you a score how the model is.
Then we'll compare the score to the reality.
Oh, okay, so it's like predictive value.
Yeah. After there is a second part that we'll do now, that is get the difference between the score and the sum of sales, and then we can compare each one of the models that you use it, and to see which of them will have the best value in the end, the smaller difference.
Yeah. Oh yeah, because we're not predicting it for a new store yet. We're
not
using the
yet.
old
No,
data.
we didn't arrive at that new point.
Basically, we're predicting
really with the past.
And then because we've got some old data, we can check.
Exactly. For now, we're only working with the past. We are first and seeing how the model works using past data, and then after all the process, we use the best model to apply to the other file that I will put here with the new stores. For now, we're working with things that we already know that happens, just to test the model, just to see if it's great or not. So let's run this course. Okay. Not okay yet. I need the girl of the program, that the old program here in UK that has a computer says no. You know that?
Yeah.
Yeah. I need someone with this. While my computer is thinking about life, the computer says no. Here is notes. Here we have one, but it's in the last one. And as you can see now, we have a score for each one of the stores. It's what we're doing here. We are comparing the score. The score is the sales predicted by the algorithm. We are comparing the score with the reality to see if the algorithm is working well in this situation. So for each one that we used here, we have the same thing. We have the score, the sum of sales, that was the data that we had before, and a score. Okay, with all the scores, what we need to do now is to, first thing, we need to calculate the difference between the score and the sum of sales. So we'll get here a formula that we will apply for all. So in the formula, let's call formula difference. because we are calculating the difference between sum of sales and score. And let's get here sum of sales less score. However, we have one problem, because if we do sum of sales minus score, sometimes I can have a negative number. And the problem is that the following step is we will sum
average.
exactly.
So you need to do absolute.
Yes, we cannot work with negatives, because the next step is we will sum all the results. So if I have a negative, it's also wrong. For instance, I have a minus 10, and the 10, if I sum both, I will have a 0, and I will have the impression that, yeah, this model is perfect. It's working very, very well, but it's not true, because I had both things were with a difference. So I will do here this way, and doing I squared difference, I will always have a positive number, what will correct the result.
Isn't there a function to there's probably an absolute, you've got ABS before it and then put it in brackets.
I don't know.
So take away what you just put there for you. Not the whole thing, just
You can
the,
have one of them, and then at
Just have
the
one.
start, just put ABS with brackets around it. The whole thing. And brackets.
It already has.
and then that should make it positive when it's negative. I think
I don't know.
that's
Would you like to test?
yes. Well, it hasn't said there's an error, so it probably
Yeah,
is right.
probably
So
right.
Yeah, that does work. You're doing the
It's
make
for-
value?
Yeah, we're correcting the
Yeah,
the
because the other
difference.
trick is power,
yeah
POW,
yeah
which is the normal way of doing it.
yeah. That's another. We can do this also. That's not. It's not POW. POW.
Power, yeah. As an exponential.
It's not working. There is no.
There's always
Sorry, that's
something.
a different way of doing it completely. Sorry. So that would be taking that to the power of whatever's after it.
You've got a hat. Use a hat up at the end.
After subtraction, after score, comma,
Yeah, and
and then what you're taking it to the power of. So if you're going to the power of 2, you're squaring it. So it would be comma 2.
no.
Right. So it's going to take that value and square it.
Okay. It's the squared. Okay. Well, so we need to do the same thing for all.
But don't we need to square root it so that we're not getting that?
Sorry?
Don't we need to square root it so we're not getting?
So then do you need to put that in an extra power thing with a half in? The whole thing is the first argument and the second argument is 0.5.
Depends on what type of value you're doing. If you're just doing the make value, then that's just squared.
You're doing what value? Make.
Mean, average, I can never remember what it stands for, but it's a type of error calculation.
You're just finding the difference.
Yeah. Mean absolute percentage error. Yeah. Well, that's the R squared value that we just come up with. Yeah. So the residual squared. I mean, as long as you're consistent with whatever error check you're using, it doesn't really matter what error check you're using. For this kind of comparison, you're just saying which has got the biggest variation from the actual. So residual, square it, so they're all positive numbers and it's easy to compare.
Yeah.
Then you say, what's the average error? Then you're done.
And that's R squared.
Yeah, so the residual is what we've got. You square that, so that's your R squared.
And we will not really use the results. We will use it only to compare.
So do you,
That's the
so
reason.
then you use the summarized to average, well, average each one.
Yes.
So, oops. I think that, okay. I think that I will do more than one process because it's taking time to run, so I will do this also. Because what we are doing here, first we created only squared values, so we have no negatives. Then we will summarize all of those values. I will do both things at the same time because it's taking too much to run. So difference, that is the file that I created in the formula. I'll get here also the difference,
Do you want the average of the differences?
the sum of all of them. I think that if you do the average, it will be the same. I think that, yeah, all of them, yeah.
Is your next step then to...
Yeah, the next step is only to compare. You only need to compare. I think that you have the same result because here you sum and see the smallest value. Yeah. But I think that if you do the average and get the smaller, it will be the same thing.
Yeah.
The important here is that we're creating a way to compare the models, and so I think that you can use both things. Okay. I will run now, and then what we'll do following this part, and because if you run for a long time now, is once you have these values now, all I need to do is to compare them to see which of them is the smaller. Why the smaller and not the bigger? Anyone would like to?
Better pair.
Yeah, exactly. Exactly. So that's the reason why we needed the smaller number here. And go Alteryx.
If you did find the average, you want the largest number, which would give you the best. That's just if you found the average. So if you found the average of all the squared values, you'd want the largest one, which would give you this. It would be the same as it would be the same model as which would give you the smallest sum. But that's just the difference between values and the average. Because then if you found the average, that would give you the R squared value, which explains the amount of variation in the model. So say if the R squared was like 94%, that means that the amount of variation in the model has been, in the data has been explained by the model 94% correctly. Does that make sense?
Yeah.
Yeah. So, yeah, the largest, you want the smallest when you're finding the sum, but the largest if you're finding the average.
Yeah,
So
if you would like to try.
So if you're averaging them, you're going to divide them by the same number for each one of these because it's the same number of data points.
Okay.
Yeah.
So if you've got smaller value on top and then the same denominator, you want the smaller, and that will give you. Wait, hold on. Is it the R squared value then? If you find the average, is that then giving you the R squared value?
No, just squaring it as the R squared.
Yeah, and then you average them.
Yeah.
That's then the R squared.
Yeah.
They said.
The average R squared, yeah.
Right, okay. So you'd want the
smallest.
Small, but usually the R squared is the amount of variation in the model which is explained. So you want a large R squared value as your ideal.
Yeah, the closer to 1 R squared is.
Yeah.
Yeah, but if you take the average, what is it going to be? A number less than 1?
So,
it could be any amount, couldn't it? To be.
I think I'm just got a bit confused because if it's the R squared, it's between 0 and 1 always.
Okay, so that R squared hasn't been normalised for nothing.
Right.
So you need to divide that value. The residual needs to be divided by the actual.
Yeah.
So that
Yeah.
there's a step in there, percentage that's been.
Okay, sorry, I'm just getting confused.
Yeah, I'm probably doing the same thing because I'm only half listening.
Right, okay. Sorry.
Yeah, because it's like the difference in sales could be any amount of dollars,
Yeah.
couldn't it? So not necessarily.
Yeah, but then when you're dividing it all by the same number as well.
Yeah, and
But then
it hasn't been normalised.
Yeah, exactly. So I think when it is, if you are finding the R squared to compare models with that one, the R squared is biggest, and we're not finding the R squared. So.
Let's back to our sums. What we need to do now is to compare. To compare them, an easy way to do that is, yeah, we can check just looking, but let's do something more professional and compare them in a beautiful way. So I will here create a field called model. What I'm doing here is only creating a column-colored model to join all this data after, and then we can sort it by descending, ascending. Anyway, we can sort by anything. Just to make it, sorry guys, it's one of my main problems because usually I use the keyboard in Portuguese, so the things are in other place. And then I'm all the time trying to figure out where stupid things are. So same thing, model, we will see that our output field model also, because then after it's easier to join. Here we are with the boosted model. Oops. Model. And here is the okay. Once we have this created, we can union the data. I'm doing 2 steps again at the same time just to make it quicker. Mm-hmm. Oh, we forgot to put that they are numbers and not, oops, now we need to wait to go back to them. Same thing. Good thing to remember, they are numbers, so they need to be described as numbers in the formula. That is exactly what we're saying here. So, sorry, no, in reality it's the opposite. They are strings in this case, and they are being described as numbers. So the string here, same thing. The string.
Oh, they need to be strings, but
yes, because what will be inside what we're creating is this name. It's boosted and linear and spline. So they cannot be defined as numbers, and they were as doubles. That's the reason why it wasn't working. So now we need to wait again. Here we go. And then after all this process is when we'll in reality use the result to define the best sort. So only after all those things, only after playing with the past, we will play with the future. We first need to check if the algorithm is working, if it fits our needs or not. So here we go. We have our models compared, and we can see that the best one is the boosted model because it has the smaller value. Yes, everybody agrees that that is our best model. So what we will do now is to use the, oh, now we have a problem. Oh, how can I find my container? I need this new container again.
Control-Alt-U.
Control?
Alt-U.
Control.
O, sorry.
What is the boosted model?
Control-Alt-O. Where'd it go? Oh.
Sorry guys, our container is a little bit disappeared. We'll find it.
So bring up the overview.
Do that. The container says no.
Do you know what it was? Let's go there.
Gradient boosting.
It came up.
Do you know what your container was called?
Container.
There we go, tool container. Okay.
It was one of those things where just like at the very end of the course that they talked about it. And then I was looking at notes for it.
Me too. You know what I can do is the same thing that we did the other time. No? I can
Came up on the exam. I was like,
put all the things inside. No?
Yep.
That's the question. It was
Oops. I was thinking about put all my things inside the container, but my Alteryx is strange again. So I'll kill those things here, and we'll keep only wow. Delete. Delete. Okay. Because what we need now is to basically to get the same information that we had before, and we will connect it with our new data that is not in our workflow yet. So first thing, input data. Here, in just now, we'll see the data that we have about the prediction. That we'll get now the data set with the stores that they are evaluating, the new store census. And as you can see, the new store census in reality, oops, here it is. We have lots of demographic data, and obviously we don't have sales data because there is no sales in our new stores. So what we'll do here, we need the, here is, oops, sorry. We'll try to organize it in a way that it will be comprehensible, but yeah. We will need the score again, the same thing that we did before. We will get the score, but at this time, what we will do with our score, instead of using the validation, the data to validate the model, now we use the data that we would like to predict something about that. So now we'll connect the data about the stores that they are evaluating with the data that we created to generate scores. And Alteryx not working again. Here it is. Okay. So we run it. And if it stops, we can go to the result and see, because the result is working. If Alteryx decide that it's, okay, I think that it's working here also. No. Is everybody following what we are doing right now? The connection of the estimation with the value of the new stores. Okay, it finished. Now what we have here is a new column where we have the score. What is this score? It is the prediction of sales for those stores that they are planning to open, but they are not reality yet. We are predicting the sales based on the same data that the same demographic data that we used to calculate it before. The same data that we used to train our algorithm. So now that we have here this score, the only thing that I need to do is to order the score to discover which is the shop that, which is the store that would have the best value of sales. So the only thing that we need to do now is to sort it based on, the score, descending, and then we'll discover which is the best one. While Alteryx is doing that, you can start to do the, what's the name of this in English, when you put money to something, for instance?
Right.
Collection.
Not collection.
Bits.
Bits, exactly. You
Place
can
your
start,
bets.
exactly.
Ah.
Which store do you think will be the, the first one? We have time, huh? We have all the time. It's on the big score yet. So it's in 12%. We have lots of time to.
That's one thing which you could do with Alteryx, is just start it from a certain point. Having to run that whole thing.
Cache macro. They're talking about bringing cache anywhere in as well, so you can do that, but it hasn't made it in yet. So, yes, they know of it.
So where you put a container and you put stuff in.
Yeah, in reality,
what's the point in that?
that's because the first one was to disconnect the container, and now the thing is that because I didn't finish, now the idea was to put everything again in the container and then close it, because this way we will not have those things interfere in your workflow.
Rather they're running.
Yes.
So
And the
if
first time, sorry, go Paul.
Sure.
No, your explanation is better than mine. Go.
I was just going to say, if you disable a container, whatever's in it doesn't run.
Oh, right.
So
Yeah.
when you take all your tools that you're not using anymore, or any section of your work that you've finished with, chuck in a tool container, disable it, and it doesn't work, doesn't run. So
Rather than deleting it, 'cause you might need it later.
Because you probably will need it again at some stage.
Rachel, could you not just use, you know, when you're in the container, you create an output, and then the next bit you use the input. Could you not have done that for this bottom bit as well? Could you not have used the input instead of doing boost and modeling?
Sorry, say again?
You know how before you created a container and created an output, and then for the rest of it you use the input, didn't you? You brought it back in with an input and used it again. Could
If I could,
have done that for this bit here? Use the input again instead of this boosted model.
The boosted model in reality, I got it again just to use it to compare. It was also in my container before.
Yeah, but
was
couldn't
it?
you, instead of taking the boosted model out of the container, could you not have taken the same input that you used earlier?
So in
The boosted Y XDB that you created, could you have used that?
Yeah, it makes all sense. Yes, I could have done it. Use only this boosted, because it's exactly the same thing, the same result, because this was the result calculated with the estimation, not with the validation. So yes, I could have done, well, I could have used it in reality, this, and connected it again, get the thing, and connect it directly. But yeah, that's exactly the same result. So, oops. Now that you have our stores sorted by score, we know that the best store to open is the store number 8. Yay! And okay, that was demonstration with the modeling. As promised, we have time, so I will only talk a little bit about this part of the limitations, because I think that it is important. Those limitations I got from this the article that is referenced here. So some limitations that you have is that the quality of your model, the quality of your prediction depends on the quality of your data. Another thing that it's very important is to have it clear what are you trying to answer. So, for instance, you're trying to answer something related to sales. So you need to think, well, which kind of data is important to answer that. Because sometimes you have lots of data, but you don't need to use all. In our case, we didn't use all the data that we had. We didn't use location, we didn't use the name of the store, things like that. You need to think which kind of data is really important to answer a question related to sales, for instance. Another thing is this part of the training. When you're training your algorithm, you need to have data that is representative of what you're trying to answer after. Here they are saying exactly that usually use data from the past to try to predict the future. That is exactly what we did in this example. Another point is sometimes it's very difficult to predict something because the thing changes a lot during the time. So not all predictions are easy to do. I think that DataGov here in UK can answer this question better than me, because in the past elections they failed. Not only in the past, they failed in the past 2 elections, in the Brexit, and also in the past election they were saying that what was the thing? They were saying that the Labour would win, and then in the end the Tory won with majority. So it's not always easy to predict things. There are things that are very tricky because you have variables that are difficult to measure or to have an idea. And there are things that change over the time also. So not always you can predict something. It's not something easy to do sometimes. And the last point is that I told you before about the policing things, the predicting, for instance, predicting the way that you policy an area, because sometimes the predictive analytics can lead to an even increased focus in something. That was the example of, obviously, if you send lots of guys to do the policing of an area, they will start to arrest more people in this area, even if the people are not committing a crime. And then in your data, you see, oh, lots of people being arrested here, so I need to send more people to police. So those are things that are limitations of the predictive analytics. So obviously it's very helpful, especially when you're talking about business and this kind of stuff. But I think that it's also important to know that as everything in life, there are limitations in it. So might find more if you would like to learn a bit more about it. And that was my presentation. If you have questions, I don't know if you have someone watching us, and I think the attendees are all here. No? No. If anyone would like to ask something? No? Otherwise, I'm finishing. First I need to stop.